We're going to continue talking about IPv4 subnetting today. And so what we talked about last time was taking a /24 subnet, and that one holding 256 hosts, and actually dividing that up. But I wanted to give you more of an overview of that process so you can see it and show you how you can do this for yourself. And this is a quick way. Now remember I said to memorize this. This is our root of our problem. We want to start here because this gives us the number of hosts in our /24 network. And I'm going to show you what we can do. What we're doing when we do the slash notation is we're just adding a bit. Every time we do it, we're adding a bit in terms of how many, in terms of essentially the network side. So every time we do this, we're actually having the number of hosts that are available. I'll show you about that /32 in a minute. But these are the number of actual IP addresses that are included in this particular network. It's defined by this boundary. So when we say we have a /28 network, what we actually have is a network that has 16 hosts in it, or 16 addresses. It may or may not be 16 hosts, but there's 16 addresses. Now, the special network here is the /32. Notice that only has one address in it. That is the way we can define any single IP address. It's a /32. So sometimes our systems may want to know what is the subnet mask of this IP address. It's a single one. All bits are set. So it's one address out of many. Now, when we start here on the side, we have a /24 network, again, with 256 IP addresses available to it. Obviously, we're not using all of them in our network definition, but we have the network boundary, we have the broadcast address, and we have everything in between. When we cut the network in half, we're splitting it exactly in half as we work down this continuum. So this is something to remember as you have as you work out the subnet creation. You can determine how large and how many hosts this subnet has in it. So I'll give you an example of, let's create a subnet. What we want to do is determine which subnet a particular IP address falls in. That's going to be a problem that you will see quite a bit given to you in the material. So I'm going to start with an IP address of 192.168.1.42, right? And I'm going to put a /24 on the end of it. Now, obviously, if we were to create a network around this with a /24, we could tell what the network boundary is. It's 192.168.1.0. We could also determine what the broadcast address is, 192.168.1.255, because it's a /24. That's easy. But what if we have a smaller network? In this case, what if I have a /26 network? So I'm just going to write this down. If I have a 192.168.1.42/26. Now, there's a particular boundary that I'm going to fall in, and in this case, if my network starts at 0 and I only have 64 hosts, my broadcast is going to be 63. So my address is going to fall within this boundary. So if my question indicated, well, what address could I use to make a broadcast packet so that the host 192.168.1.42 could actually receive that broadcast, well, I have to go in and have to create a network here. So here's my host at 42. Here's my broadcast address at 63. Now, I can use this counting method to determine what network any address is given the size of the network. So what may happen is that I may be given a specific subnet mask. And in this case, the subnet mask here is that all 24 bits of this are set. So in a /24, my subnet mask is this, 255.255.255.0. When I begin to look at smaller and smaller networks, my subnet mask is going to change based on the number of hosts that are available. So I'm going to keep adding bits over to the as we go to the right. We're going to keep adding bits to create smaller and smaller networks. So this is just a way we can actually use to subdivide this. So remember, I'll go over it one more time. When we take this network, we're going to first start and we're going to determine what is our boundary. Two, what is our broadcast? Remember, the broadcast is always the last network. The boundary is always the first. So I'm going to take this network right here as one final example. It's a /29. What are the network boundaries? And we're just going to count by 8. These are all of our network boundaries. So it doesn't matter what my network is. If I have a /29, I could start this with any set of IP addresses. And these are all of the networks that I can create that are /29s, and these are their boundaries. So as we want to keep going, we can determine what is the broadcast address. And so on and so forth. These are our networks in which we defined. In this case, they're /29. We can do this with any size of network. And as we go through this continuum, we can even go even more to the left. But this is how we actually create and define networks. And a lot of this is arbitrary, so don't let yourself get confused when you see people have defined a network a certain way. They're arbitrarily defining this 10.0.0, for instance, or the 192.168.1. That's an arbitrary designation. I could easily call that 10.0.1 or 10.200.1.0, 192.168.5. I can come up with any network number because if I keep counting, at some point I'm going to reach that network. So this has been another example of IPv4 subnetting. Thank you very much.